Welcome to This Explainer. Today, we're diving straight into a massive global mystery. We are dissecting a digital bank heist so large it's almost hard to wrap your head around. And, more importantly, we're looking at the revolutionary AI detective that's being built to stop it in its tracks.
Okay, let's get right into this staggering figure. $4 trillion. That is how much financial fraud costs businesses worldwide every single year. To put that into perspective, that's roughly 5% of their total sales just vanishing into thin air. We're talking the whole shebang here. Money fraud, identity theft, sophisticated embezzlement. It is a massive global economic threat. And frankly, the stakes in the financial sector have absolutely never been higher.
So, you're probably wondering, why is that number so astronomically high? Well, the reality is that traditional, rigid rule-based systems simply aren't cutting it anymore. They literally cannot keep pace with the clever evasion tactics used by modern digital fraudsters. As digital payments have completely exploded, these older systems, which rely on super strict, predetermined criteria and manual thresholds, are just falling wildly behind. They're throwing up tons of false positives, and they just fundamentally struggle to recognize complex, constantly evolving criminal behavior. It's kind of like trying to catch a modern sports car using a horse and buggy. Which brings us to a really fascinating question. If you had to guess the most common time for a financial cybercrime to strike, when do you think it happens? Do you picture a lone hacker in a dark room wearing a hoodie at 2 in the morning? Hold on to that assumption for a second, because we're going to look at the actual data. Okay, looking at the data here, it completely busts that midnight hacker myth. This chart maps out transaction frequency by the hour. Up top, those blue bars represent normal, everyday transactions. Down below, the orange bars represent the fraud. Now take a really close look at that distribution. Fraud is absolutely not clustered in the middle of the night. Actually, scratch that. It completely peaks during normal business hours, right around 10 to 11 a.m. It perfectly mimics our typical banking and business hours. What this tells us is that modern digital thieves are intentionally hiding in plain sight. They're blending right into the daily rush of legitimate transactions so they don't set off any alarms. And these criminals have highly specific habits. If you look at the heat map down there, mapping the days of the week against the hours of the day, pay attention to those darker red areas. That is exactly where fraud is concentrated. We're seeing intense midweek spikes, specifically on Wednesdays and Thursdays during the late morning. And check out the box plot right above it. It reveals a really surprising reality. Fraudsters actively target accounts with much higher balances. So they aren't just spraying and praying, they are incredibly calculated, hitting well-funded accounts right in the middle of the busy work week. Furthermore, let's look at the actual transaction amounts. Comparing the normal accounts with the fraudulent ones, you'll notice the boxes here are nearly identical in height and position. What does that mean? It means the monetary size of a transaction alone won't tip off the bank anymore. Criminals are executing what we call micro frauds. These are small, perfectly ordinary-looking transactions, specifically designed to slip right past simple security alarm. So the absolutely crucial takeaway here is how these two behaviors contrast. While you and I, the legitimate users, have a wider, kind of random spread of transactions across different times and different amounts, modern fraudsters are highly methodical. They execute these subtle micro-frauds from high-balance accounts, specifically during peak midweek business hours. They do this precisely to evade detection. They are actively studying and mimicking the baseline of normal user activity to slip past the traditional security rules we just talked about. Let's see how all this builds a suspect profile. Look at this radar plot. It's mapping out key features, like the hour of the day of the week, the transaction amount, and the account balance. That large blue triangle stretching outward, that's normal activity. But look near the center, those tiny orange lines, that is the fraud. This visually proves a massive point. While one single clue might not scream fraud, specific combinations like timing crossed with account balance create a highly predictive, totally unique geometric signature. It proves for sure that we need a system capable of looking at multiple, complex feature interactions all at once, rather than just ticking off single traits on a checklist. So to catch these subtle, complex crimes without accidentally locking out thousands of legitimate customers, banks desperately need a new kind of tool. They need explainable AI, or XAI. Explainable AI is exactly what it sounds like. It's artificial intelligence that can transparently provide clear, understandable justifications for its decisions. It doesn't just give you a yes or no answer. It tells you exactly why it arrived at that answer. And in the highly regulated financial sector, that kind of transparency is absolutely critical. But this brings us to a really major hurdle, known as the black box problem. You see, traditional deep neural networks are incredibly powerful at finding complex patterns, but they kind of act like a giant magic 8-ball. They take in mountains of data and just spit out an answer. fraud or not fraud, without showing their work. For banks, this is a massive compliance and trust nightmare. Imagine freezing a massive corporate client's account and having literally no ability to explain to auditors or the client themselves why the system flagged it. Banks absolutely must have transparency for dispute resolution and regulatory compliance. Enter our hero for today, TabNet. TabNet is this incredible adaptive deep learning architecture that acts like a master detective. First off, it processes tabular data, like your standard everyday financial spreadsheets, natively, without needing any complex translations. Second, it uses a brilliant mechanism called sparse attention. This allows it to dynamically select and focus only on the most relevant clues at each decision step, totally ignoring the background noise. And third, and most importantly, it delivers built-in interpretability. It can actually explain exactly why it flagged a transaction, showing investigators the exact data points that led to its conclusion. But before TabNet could solve the case, researchers faced a massive real-world hurdle with the raw data itself. Take a look at this heavily skewed data set. The massive blue bar on the left represents over 62,000 normal transactions. The tiny little bar on the right? That's just over 3,200 fraudulent ones. It's a total needle in a haystack situation. If an AI just wildly guessed not fraud every single time, it would look highly accurate on paper, but it would be completely useless in practice. The AI needs enough examples of the actual crime to learn the pattern. So to fix this, the researchers utilized a really clever technique called SMOTE, the synthetic minority oversampling technique. Look at the result here. We now have two perfectly equal bars balancing out at over 62,000 transactions each. What SMOTE does is it creates synthetic, mathematically accurate examples of the fraud based on the real data. This ensures the AI has a completely level playing field to train on. It essentially forces the AI to actually learn the underlying patterns rather than just playing the odds and guessing normal every time. Okay, so with the data perfectly balanced, they deployed this structured end-to-end workflow you're seeing here. Up in the top pipeline, the raw data is loaded, cleaned up, and balanced using that SMOTE technique we just talked about. Moving down the diagram, TabNet is put through rigorous testing. It splits the data into 3 different batches or folds to ensure the model isn't just memorizing one set of answers. Finally, down in the bottom right, TabNet's performance is strictly compared against older traditional deep neural networks. This modular step-by-step design ensures absolute reliability when it's pushed into real-world scenarios. And wow, when they pitted them in this ultimate tech showdown, the results were just staggering. Look at this table. TabNet completely blew away the competition, consistently identifying fraud with 97% accuracy across all the tests. Now, look at the traditional models below it, the GRU, LSTM, the standard DNNs. They are hovering right around 50%. Because of the incredibly complex nature of financial spreadsheets, those older AI models were effectively just flipping a coin. TabNet's unique ability to focus on specific feature interactions made all the difference in the world. And TabNet's sheer dominance is finally proven by this ROC curve. This is a tool data scientists use to measure exactly how well a model distinguishes between two things, in this case fraud and non-fraud. The ideal curve pushes as far into that top left corner as possible. Look at TabNet's blue line just perfectly hugging that corner. What this means in plain English is exceptionally low false positives, so it won't embarrassingly freeze your card when you're just trying to buy a coffee, and exceptionally low false negatives, meaning the digital thieves simply can't slip through. It is the perfect, transparent tool to secure our financial infrastructure. So I want to leave you with this thought to ponder. If TabNet proves that AI can now catch nearly invisible digital thieves hiding in absolute mountains of spreadsheet data, and crucially transparently explain its exact reasoning to human regulators, what other impossible mysteries will we trust it to solve next? The age of the black box AI is officially ending, and the era of the transparent AI detective has just begun. Thanks so much for joining me on this explainer, and I hope this gives you a much clearer picture of how technology is evolving to keep our digital world safe.